Hi, I'm Sochil, and my role today was recording the balls bouncing and then taking the heights at each point.
Hi, I'm Hunter Ludwig, and I did the measurements and calculations.
Hi, my name is Sean Ariana. I also did measurements and calculations.
Hi, I'm Rachel Hernandez. I did a lot of theory and questions.
Hi, my name is Trish Tran, and I did most of the recording of the video and the experiment.
Oh, so it is Monday at 9 a.m. and we just finished our hands-on exercise 1, where we calculated the coefficient of restitution of different balls on different bounce pads, and the coefficient of restitution is the ratio of conserved kinetic energy during collisions. And we can find the coefficient of restitution by taking the square root of the height final over height initial, and we expect that number to be less than 1.
So our goal for this experiment is to determine what is the highest coefficient of restitution between the two materials, and this is relevant to our major because it is giving us a fundamental understanding of materials and properties. We expect the maximum coefficient of restitution to be Durling and acrylic based on its properties of plastic, and the minimum coefficient of restitution to be neoprene and rubber because it's a squishier material and it'll absorb more of the shock.
Alright, and for the materials that we used, we chose to do Berlin ball on acrylic. Wood ball on aluminum. Steel ball on aluminum. And neoprene ball on aluminum. We found that our highest average for restitution was with the Durlin on acrylic with an average of 0.847, and the lowest we had was neoprene ball on aluminum plate, which was a restitution average of 0.503 average.
So, in conclusion, we determined that Delrin on acrylic was the best combination. It would produce the highest coefficient of restitution. And during the experiment, we noticed a couple of errors. One of them being that whenever the ball would bounce, we'd have a hard time telling its exact position or height on the meter stick. One way this could be improved is by adding a photo gate, which would be able to tell the exact difference in heights and produce a more accurate restitution. Also, we noticed that whenever the ball would bounce, it would sometimes translate on the x-axis, which means that we would lose some amount of energy going in an opposite direction. And yeah, so that's our experiment.
Oh, before we conclude, real world cases, Major League Baseball players have to use wooden bats instead of steel bats because steel bats have a higher coefficient of restitution and they would just be hitting home runs. And another case in which the coefficient of restitution is helpful is the landing on Mars, where we would have to cushion the impact with air pockets, so the landing is absorbed. And that concludes exercise 1.